All right, good morning, and how are we doing? So, we are going to get started on two ways to solve systems of equations. So, first thing you need to know is why is it called a system of equations? And a system just simply means, so if I had a system of gears, right? So that means that I have more than one. In this case, a system of linear equations is just going to be more than one equation. So these are two equations together that are going to be considered a system. And we want to know, how can we solve this? And by solving a system of equations, you're determining where they intersect. And this can be done in two different ways. The first way is by graphing them. So we can graph two lines and determine where do they cross paths. That's going to be one system of equations. And then the next system, or that's going to be one solution. And then the next way that you can figure it out is by substitution. And I'm going to talk about both of those ways today. So this one might be a little bit of a longer video, but I want us to really understand how to do this. So, and this is important because when we're graphing different types of objects on a plane, you're going to need to know where two lines intersect in order to figure out certain geometric properties of them. So that's why this is important as part of the foundation. Like I said, this entire unit, algebra and functions, is foundational for what we're going to do in geometry. It's not the fun stuff yet. It's not exciting, but it is foundational. You got to know how to do this stuff first. So first things first is, in order to solve a system, you need to rewrite each equation in slope-intercept form. And in the last video, I talked about what slope-intercept form looks like. It looks like y equals mx plus b, okay, where m is the slope and b is our y-intercept. So it's where it crosses the y-axis. So in order to solve this system, you need to have both of those looking like slope-intercept. So in this case, we have 4x plus 2y equals 4. And if you go back to solving for variables, we are solving for y because we want it to look like these. That's a terrible arrow, but we want it to look like that. So we have 4x plus 2y equals 4. So we want to get y by itself. So we need to get rid of everything over here on this side of the equal sign that is not y. So I'm going to subtract 4x from both sides. And I'm left with 2y equals, 2y equals 4 minus 4x. Okay? So now what we want to do is get y by itself. So divide by 2. The inverse of multiplication is division. So now we have y. Why do I keep doing that? Y equals, what is 4 divided by 2? So that's 2 minus 4 divided by 2 again, 2x. Okay, or you can just rewrite this as y equals negative 2x plus 2. Either way, that is sufficient. Okay, but we now have one of them, and that's this one. And then the other one I'm not going to get into, but it comes out to be y equals 2x minus 6. So I'm not picky about how you plot these. If you want to go to Desmos and use Desmos to plot them, that's fine. I'm not going to be really picky about that, but I just want you to know that where those two lines intersect, their point of intersection, so where they cross is going to be your solution. So in this case, when we plot these two equations in slope intercept form, then you're going to have a point here where they cross. And that point is your solution. So the solution to this is 2, negative 2. That's the point. That's the coordinate. Okay, so that's how you solve a system of equations, find a solution to a system of equations by graphing. Okay, so let's do one example and then we'll talk about another way. Okay, so we have these and we want to put them, first thing we need to do is put them in slope-intercept form. So y equals something, and these should be relatively easy. And then we're going to plot them and see where they cross. Okay, so x plus y equals -1. Well, y is going to equal -1. And then all we have to do is move the x to the other side. And in order to do that, you subtract x from both sides, minus x. Okay, or -x minus 1, however you want to do that. And then on this one, we need to subtract 4x on both sides. So you're going to get -2y equals -16 minus 4x. Divide both sides by -2. Y equals 8. -16 divided by -2 is 8. -4, so that's 2x. And we'll just say y equals 2x plus 8. That is the same thing, okay? So both of those problems we need to plot on this graph. And when we do, we should see where they intersect. So let's go ahead and plot them. Let's plug in 1 to start with. Actually, you know what? I'm going to create a table and then we'll erase it. So x and y. So first we're going to plot y equals -1 minus x. Okay, so let's just say -1, 0, 1, 2. We're going to plot all these points. When I plug in -1 for x, I'm going to have -1 minus -1. -1 minus -1, that's going to be -1 plus 1, so it's going to be 0. Okay, and keep plugging in those numbers. So plug in 0 for x. -1 minus 0 is -1. 1, so -1 minus 1, -2. 2, plug in 2, so -1 minus 2, that'd be -3. So these are our points. So we're going to plot these as coordinates. So -1, 0, -1, 0. If you look at my little graph here, I'm plotting this point. Okay, -1, 0, 0, -1, so 0, -1. Okay, 1, -2, 1, -2, and 2, -3, 2, -3. Okay, so there we go. There's one line. Okay, where I've plotted those points. And now let's do another. We'll do the second one. So it's y equals 2x plus 8. Let's get a table of values. 2x plus 8. Like I said, I'm not picky about how you graph these as long as you figure out where they intersect and find the solution. So 2x plus 8. So let's do the same thing. Let's do -1, 0, 1, 2. So 2 times, I'm going to say 2 times -1 plus 8. That'd be -2 plus 8 is 6. 0, 2 times 0 plus 8 is going to be 8. 1, okay, so 2 times 1 plus 8, that's 10. And then 4, 2 times 2 is 4 plus 8 is 12. Okay, so we have -1, 6, 2, 3, 4, 5, 6. There's 1 point, 0, 8. And it goes up a little bit, you can't really see that. Okay, 1, 10, 2, 12. So I actually want to go in the other direction because I'm noticing that that's going to happen. And we're going to keep hitting points. So this right here, oh, right here. if I plug in negative 3, we'll plug in negative 3. So 2 times negative 3 is negative 6 plus 8 should be 2. Negative 3, 2. Okay, and that should also be the same point here if I was to plug in negative 3, 2. So this is our intersecting point, negative 3, 2. And that's your solution. Okay, so that's 1, and I want you to do the rest. I'm going to erase all this so that it's not messy on your end. Okay, and where they intersect will always be the solution. So pause this and do 2, 3, and 4. Then we're going to come back and we're going to talk about how to do it a different way. So the second way that you can solve is by substitution. This to me is probably my most favorite way. But let's get into it and just figure out how we're going to do this. So you can also use substitution. Substitution simply means that you're going to substitute something, right? Well, in this case, you're going to substitute the y. So notice how this is y equals something, right? Y equals x plus 2. Well, what we can do is substitute one of the equations. In this case, if y equals something, I think I'm going to plug in whatever y equals in for y in the other problem. That's going to be substitution. So you're going to choose the equation you want to use as a substitution. In this case, we're going to use the first one just because it's already y equals something, so why not? And if it was x equals something, you can plug it in for x. So that's what we'll do here. Now we know that y equals x plus 2. So we're going to substitute that in for y. So you'll have 3x plus y, which is x plus 2 equals 10. And you'll substitute. So you'll combine like terms. 3x plus x is 4x plus 2 equals 10. And you're going to keep solving until you get something for x. And you have x equals a number. That's perfect. That's exactly what you want. Now, your next step is probably the most imperative. You're going to substitute x equals 2. So whatever you got for x, back into one of the original equations. If you go back, our originals are y equals x plus 2 and 3x plus y equals 10. So you'll plug it back in to find a solution. Now you can do either one of these. It doesn't matter which one. I would probably do the easiest one, and to me the easiest one would be plugging it into x plus 2. So if I got 2 for x, I'll go y equals 2 plus 2. Okay, so y is now 4. So your solution is your x value that you plugged in and your y that you got out. Okay, and in this case we plugged in 2 and we got 4. Okay, and now you can substitute 2 and 4 into both equations if they both work. So when you plug it into y equals x plus 2 and you get 4 equals, so that's your y, and then you plugged in x. If you get 4 equals 2 plus 2, then you know that your solution works. This is one of those things that you can always check to make sure that you're correct. So let's do a practice problem really quickly. So y equals x plus 2 and y equals 2x minus 5. So what we can actually do in this situation is we can plug it in. Well, so let's see. Y equals x plus 2. So we can let's plug this in as y in the second equation. So x plus 2 equals 2x minus 5. So now what we want to do is solve for x. So let's just get x by itself. Let's subtract 2 from both sides. So I have x equals 2x. Negative 5 minus 2 is negative 7. Okay, and now I want to get all my x's on one side and all my numbers, my constants, on the other side. So let's subtract 2x. Now we have x minus 2x, which is negative x, negative 1, equals negative 7. This is the same thing as saying x equals 7, because if you divide both sides by negative 1. So x equals 7. So let's plug that in and see what we get for our solution. So we can plug it into either one of them. So y equals, and what did we get for x? 7. Y equals 7 plus 2. Well, y is now going to be 9. Well, we knew what our x was. Our x was 7, and our y is 9. So there's your solution. 7, 9. That's our coordinate. Remember, your solution to a system should always be a coordinate. All right, so pause this and do 2 through 4. And if you have any questions, do not hesitate to email me or fill out a help form.